Today we're going to talk about how energy flows through an ecosystem. As you notice here, everything eats. And we're going to talk about that. So, some learning targets that we have for today. We're going to define some terms. We're going to explain how energy can be transferred from one organism to another. And we're also going to calculate energy from one trophic level to the next. Let's first start by defining an ecosystem. An ecosystem includes all living and non-living things in an environment. Everything is either living, biotic, or non-living. So here in the picture, we see both living and non-living things. So while there's grass, there's also the sand, and there's the trees. And so all those things are either living or non-living. So let's break down the word biotic and abiotic. Bio means life or living, while a means not, and so not bio meaning not living. Alright, so here we see two different pictures. I want you to list which things in the pictures are abiotic and which things are biotic. I'll give you a moment. Alright, let's start with abiotic. First, I see water. And although lots of life requires water, water itself is not alive. In fact, we drink the same water that dinosaurs drank, which is amazing. Also, I see sky, and I'm assuming there's air, and air also is not alive. Air is just a bunch of gases. So we have water and air. What else do we see? Well, I see the elephants are standing on what appears to be dirt. So dirt is not alive. What's biotic? First, you see tigers. I see elephants. Did anyone catch the plants? Those are alive. And here's a tricky one. Soil. You might be thinking, wait, you just said dirt's not alive, but what about soil? Why is it biotic? Well, soil is actually a little bit different than dirt. Soil actually includes living organisms in its definition. So it includes dirt plus maybe decomposers like fungi. So have you ever wondered why you eat? Have you ever thought about that? It's just so fundamentally natural to us to want to eat. But why? Well, we burn calories when we do things like run or even sleep. In fact, we are always burning calories. So what exactly is a calorie? A calorie is the energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. Calories, therefore, are units of energy. 1 calorie equals 4.18 joules, which is another form or unit of energy that we will be using later. So there are many different types of feeders, meaning many different ways in order to gain energy. Some organisms make their own food. They're known as autotrophs. If we break down the word autotrophs, we see auto, which means self. Think of an automobile. It's something where you can drive it around yourself. Troph means feeder. You put those two words together and you have self-feeder. Something that creates its own food, like plants. How do plants make their own food? Well, photosynthesis. They convert sun energy into food energy using photosynthesis. Some organisms rely on consuming other organisms for food. These are known as heterotrophs. Hetero means other. Troph, again, means feeder. So what does that put together? Heterotroph means other feeder. Some examples. Panda bear. The panda did not create its own food by itself. It found food, in the case here, it found some bamboo, and is consuming it to gain energy. So there are multiple different types of heterotrophs. There are herbivores, organisms that eat only plants. Examples of those include cows, bunnies, mice. Omnivores are another type of heterotroph. They're organisms that eat both plants and meat. Can you think of examples of those? How about yourself? Or a bear? Also, there are carnivores. Carnivores are organisms that eat only meat. For instance, a tiger. Have you ever seen a tiger eat a bowl of lettuce? Well, you're not going to. And what about this guy? I have no idea what type of feeder he is. Write down on your sheet what type of feeder you would think he would be, but provide explanations. Here we have a food chain. What exactly is a food chain? It's the order in which organisms consume other organisms in an ecosystem. So here on the bottom right, we have a food chain in which the plant is eaten by the grasshopper is eaten by the mouse is eaten by the snake, and the hawk eats the snake. So that's a food chain. However, trophic levels show the position of an organism in a food chain. You see here on the plant is considered the primary producer. And then you have a grasshopper, which is the first one to eat the primary producer. So therefore, it's considered the primary consumer. It consumes the producer. And then you have the mouse and so on and so forth. So we're going to take a look at how energy is transferred through these different trophic systems. One thing I want to take note of is that some animals can be in different trophic levels. A trophic level is determined by what the animal ate. So while a lion, for instance, can eat a primary consumer like a cow, a lion can also eat a crocodile, theoretically. Maybe. I'm not really sure who would win in a fight. But a lion could theoretically eat a crocodile or an owl, which would make the lion a predator or a secondary consumer. What would happen if you ate a sloth? Please don't eat a sloth. They're really, really cute. But in a hypothetical world, what would happen? Your body would extract the energy stored in the sloth, but say that the sloth had 2,000 calories of energy. Does that mean that you are getting 2,000 calories? 8,360 joules? No. Little secret. Everyone, and I mean everyone, poops. I mean, elephants poop. There's even a book about everyone who poops. And even the Queen of England poops. So why is that important? Well, some things can't be digested, so it's defecated. That's another fancy word for poop. Therefore, the energy from that food is not transferred to the next trophic level. Let's take a look at this picture in the bottom right. Can you identify the primary producer in this picture? It's the grass. What about the primary consumer? That's going to be the horse. And what about this big pile on the bottom right? That looks like poop. And it is. That was originally grass that went through the digestive tract of the horse, and a lot of it was defecated. But why? Why was so much of that grass defecated? Well, let's take a closer look. Most of that grass is cellulose. Cellulose is something that's very hard for horses to digest. Therefore, a lot of the energy from the grass is not actually taken in by the horse. Instead, a lot of it is lost through pooping. Also, energy is lost from digesting food. It takes a lot of energy to digest food. Have you ever had a large meal and get a food coma? Maybe after Thanksgiving, you get really sleepy afterwards because your body says, all right, I'm going to take a break from your brain and I'm going to send some energy to your stomach. We got some work to do. So how much energy is lost from one trophic level to the next? let's think about that grass and the horse. How much energy do you think was lost from the grass to the horse? Do you think it was 1%? 25%? Make an educated guess. The answer is 90% is lost between trophic levels. So let's take a look at this graph here and this figure. Here we see that there are 1 million joules, again, a measurement of energy, that enters the system. But only 10,000 of those 1 million joules are taken in by the plant. And then only 1,000 joules are taken in from the grasshopper from eating that plant, and so on and so forth. Therefore, one thing that we find is that there are more primary producers in the world than there are, say, carnivores, things that are maybe tertiary consumers. Interesting fact, huh? Fill out your worksheet, answer the questions about this little turtle and the big strawberry.